In each of 28 through 31, part A says rewrite the theorem in 3 different ways. As for all blank, if blank then blank. As for all blank, comma blank, without using the words if or then. And as if blank then blank, without using an explicit universal quantifier. And then fill in the blanks in the proof of the theorem. So the theorem is the negative of any integer is even. So we'll start with the first part. For all blank, if blank, then blank. So the for all part is going to represent the types of objects that we're working with. I'm going to also instantiate a variable here. So for all n, where n is an integer, if n is even, then negative n is even. For the next part, we need for all blank, comma blank. So we have to rewrite this statement without even using the words if or then. So we would say for all even integers n, comma negative n is even. And then last, we need to write this as if blank then blank without using an explicit universal quantifier. So we would say if n is an even integer, then minus n is even. So that's part A. Part B says we need to fill in the blanks in the proof of the theorem. So it looks like there are 4 parts here. A, B, C, and D. These are the blanks that we need to fill in. Let's start with A. And keep in mind we're doing part A within part B. It's a little weird, but let's read this proof. Suppose n is any particular but arbitrarily chosen even integer. We must show that negative n is even. By blank, n equals 2k for some integer k. Now this right here is the definition of an even integer. That means A must be definition of an even integer. So now it says by definition of an even integer, n equals 2k for some integer k. Then negative n equals negative 2k. Here we could see that 2k is the same thing as n, so we're plugging in 2k into n. That means that B is by substitution. Then we use the commutative property of multiplication to bring that negative in between the 2 and the k, so that it's 2 times minus k. Let r equal negative k, then r is an integer because negative 1 and k are integers. And part C. So we've already established that negative 1 is an integer and k is an integer, but that doesn't necessarily mean that negative k is an integer unless we clarify for part C that the multiplication of 2 integers is an integer. So this is important to show that r is an integer. Next we have hence negative n equals 2r, where r is an integer. And so negative n is even by part D. So to clarify here, negative n is 2 times some integer. That means that negative n is even. But why is that? That's by the definition of an even integer. The definition of an even integer is that you can write that integer as 2 times some number r, where r is an integer, or k, or any number really, so long as that thing is an integer. And that answers this question. Thanks everyone, and I'll see you in the next video.